All right, all right, all right. Matthew McConaughey's my no, that's not no. We better not do that. This is Mr. Minnick. Mr. Minnick's my name. Math is my game today. My Algebra II class is looking at Chapter 2, Section 1. This is our second official section out of the book. Chapter 2, Section 1, the title's Relations and Functions, and this has nothing to do with Wyndham. And this has nothing to do with West Virginia. And if that offended anybody who's from West Virginia or Wyndham, I'm sorry. You know, in Wyndham, everybody's related to everybody. You're like, yeah, do you know Joe whatever? Yeah, dude, he's my cousin. And if you're from Wyndham, you got to end the word cousin with a T because it ends with a T. You don't say cousin? You know, people from Wyndham say cousin with a T. I don't get it. I don't get it. I'm actually related to some people from Wyndham. Okay. This Common Core content standards business, someday Miss Kissabeth is going to be in here observing me, and I'm supposed to, if I'm doing my job right, I'm supposed to include these with each lesson. Whatever. So anyway, that's what the national content standards are. You're supposed to understand that a function assigns to each element, blah, 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 blah. So all that's there. What I would jot down if I was taking notes on this lesson, I would jot down the title for sure. And I would jot down this first definition right here about a relation. A relation is a set, and I'll simplify it for you. I'll make it a little bit easier. It's a set of ordered pairs. It's simply a set of ordered pairs. Now the book, they say that it's a set of input and output values. That's true. And those inputs are x's and the outputs are y's, but a set of ordered pairs, that's all we need. Now the next sentence that they have after that definition, you need to be aware that there are four ways. There are four ways to represent one of these things, and you're responsible to know all four. On the quiz that you're going to take on the day after tomorrow, you'll have to do that. So the four ways to represent relations, I really like the way they did this. They used the exact same relation each time. They have ordered pairs. So they have -3, 4. They have 3, -1, 4, -1, and 4, 3. And then they've got, so that's one way, this ordered pairs business. This ordered pairs business. All right, so ordered pairs is one way that you can write out a relation. When I set these things up as ordered pairs, because they say set, I would probably actually prefer to see it written out this way with the braces, you know, in this -3, 4, 3, -1, 4, -1. I think just for space-saving purposes, they wrote it out in the fashion that they did. But keep in mind, because this is a set of ordered pairs, we would need to have braces closing these things in. So ordered pairs, that's one way to represent a relation. The mapping diagram, I'll just refer to this as a map. Same thing, mapping diagram, a map. Notice that there's a heading for inputs and a heading for outputs. And notice when they list those numbers, that they list those numbers for the inputs in order. They have the smallest number at the top, the -3, and then the +3, and then the 4. And they didn't really worry about the order for the outputs. That's kind of weird they did the way they did that. 4, -1, and 3. But there are these arrows. This says that the -3 corresponds to the 4. This says that the 3 corresponds to -1. It says 4 corresponds to -1 and 4 corresponds to 3. So those arrows, that's kind of a big deal. That's a really big deal with the map. You need to have those arrows. So the input heading, the output heading, all the X's are in the inputs, the Y's are in the outputs, but there's an arrow that says which X goes with which Y. And those arrows always point toward the right, from left to right. Does anybody have any question, comment, concern, short debate about the map? If you were given a map, would you be able to write out the ordered pairs given a map, you think? Okay. Cool beans. So moving right along then, this table of values, I think it speaks for itself. An X and a Y. Boy, green's a bad choice of colors on that. X and a Y. And then we put the X's and the Y's corresponding right down the table like that. So you've seen those, I'm sure, before. So that's nothing new. And finally, the graph. I don't like that they didn't label the graph, but you've seen graphs before. So I'm assuming this is at point -3, whatever it is, what, -3, 4 up there. And then here's the point, what's that, 3, -1. And then 4, -1. And then, what's that other one, 4, 3. 4, 3. So 4 ways to represent relations. Make sure that you could recreate all 3 of them given one of them. Because on the quiz tomorrow, I think you're going to have to do that. You know, they might give you the graph and you would have to write out the other 3. They might give you the table and you might have to make a map or list out the ordered pairs or list out the graph. Okay. So far, so good? I want to know why they start pronouncing words the wrong way when they sing. Did you ever notice that? When people sing, they don't say words the way that they're supposed to be said. I sing, and I notice it, but I try not to sing like that. Like the word good, they don't say good, they say goid. There's this one song I like, and they don't say good, they say goid. It's really weird. Anyway, problem number 1. Somebody's jumping from an aeroplane. They've got a mapping diagram. They've got the ordered pairs. Notice, oh, I like this. Look what they did when they listed out these ordered pairs. Do you see how they did put the braces after all? That's awesome because it's a set of ordered pairs. So they wrote out the ordered pairs. They put a table of values, and when somebody jumps from the plane, they're jumping from an altitude of 10,000 feet. After 4 seconds of free fall, they're at 9,744 feet. After 8 seconds of free fall, they're at 8,976 feet. After 12 seconds of free fall, they're still up there at almost 8,000 feet. And after 16 seconds of free fall, they're still at 6,000 feet, a little under 6,000 feet. I really like this example. I think it's pretty cool. I think it's pretty neat to see what happens with the altitude over time. Pretty cool. Could you imagine that, 16 seconds of free fall? That's a long time. 1, 2, ready, jump. Ah! Where's the parachute handle? You guys have heard this one. This is an awful joke. I shouldn't tell this. I forget how it goes. What's the difference between a bad golfer and a bad skydiver? One goes whack, darn. The other goes darn, whack. Pretty bad. Pretty bad. So how can you represent this? So they already kind of gave us the answers. Let's move on to the next one. Using the relation from problem 1, what are the domain and the range? So I need to grab one of those. I want to take a picture of one of those. And you know what they say about taking a picture? They say take a picture to last longer. That's what Pee Wee Herman used to say. Do you know who Pee Wee Herman was? I like that show. So what do we want? Do we want to grab the map or the ordered pairs or the table of values or the graph? What do you want? The table of values has got something in the way. I can't move that. No. The map. Okay, so we'll grab this from the map. So I want to grab this from the map. And I want to send it to the current page, and I'm just going to go ahead and cut it out of there. Cut it out. Then we'll paste it over here. So they're asking us, okay, what's the domain? I'll abbreviate domain this way. I'll just put a capital D like that. That means what's the domain? This is the domain. It's the following things. Anybody think to know what it is? 0 to 16. Now up here, notice the definition of domain. The domain of a relation is the set of inputs, or the x coordinates essentially. So it is going to include 0. It is going to include 16. Is there anything else in there? 4, 8, and 12. 4, 8, and 12. How do I keep them separated? Commas. Braces. Got to have those braces. Without the braces, it would not be all the way entirely right. So the range, same kind of thing with the range. Some textbooks are very particular. They want you to put the range in numeric order from smallest to largest, in ascending order. And I didn't say the A word, I said ascending order. Okay? That's A-S-C-E-N-D, ascending order. I'm not real picky about that, as long as you have them all, but I will just go ahead and put them in ascending order. So we got 5904, comma, 7696, comma, 8976, 9744, and 10,000. Here's an interesting proposition. Should I put the comma in between the 10 and the 1,000 for 10,000? Probably not. It's going to get confusing. So what else do I need here? Braces, yeah. So I don't think we defined a range, but hopefully you can see that since the domain is the set of all the inputs, the range is the set of all the outputs. Okay. I got to be honest with you. This lesson, this homework, this is probably the second easiest thing we're going to do this year. Most of this should be really straightforward. There's going to be parts of it that are a challenge. There is a certain component, a certain facet, a certain idea about domain and range that makes this class difficult. You want to see it? You ready for a challenge? As a matter of fact, this showed up on the pre-assessment, if I'm not mistaken. Now, for whatever reason, my smartboard says, yeah, dog, we're not doing that. It doesn't like me sometimes. I'm not even mad at it. Suppose this is E and this is G. Remember earlier in the year I said E is a bad choice of variable? It is. But suppose they're talking about this E being some independent variable, something that happens regardless of something else. Suppose it's eggs. Suppose it's the number of eggs. Suppose it's the number of eggs. Anybody ever make an omelet? And then the G might be the ounces of grease. Anybody ever try to cook eggs without grease? They stick to the pan unless you have a really nice pan. So what should that look like? As the number of eggs increases, the number of grease would do what? Also increase. If we don't have any eggs, we don't need any grease. So that might go right here, right? But if we have something like 5 eggs, we might need to have 1 ounce of grease, right? So maybe this is going to go something like this. And then maybe if we have 10 eggs, we might need to have 2 ounces of grease. And if we have 15 eggs, maybe we still only need 2 ounces of grease. Does that make sense? Maybe? So suppose we have something that looks like that. Whoop, whoop, whoop. So let's think about the domain here. Let's think about the domain here and the range here. This is kind of tricky. And if I was a betting man, I would bet that nobody in here could tell me the right way to write it. And that's okay. It's not your fault. You haven't been taught this. Everybody want to take a shot at it, what the domain is? It's all the x values. 0, 5, 10, 15. That's 0, 5, 10, 15. That's 4 of them. Keep going. And then everything in between. So we'd also have to put 1, 2, 3, 4, 6, 7, 8. But then we'd have to put everything between 0 and 1. Really? Are we going to be able to write that out? Not easily. So to write the domain, sometimes we need to write it a different way because let's face it, I don't think we're going to take the time to say, well, the domain's got 0 and 0. Dang it, I didn't mean to do that. And 0.1, 0.0000001 and 0.0000002 and 0. That's going to take forever. So what we do is we use this idea called interval notation. You probably want to put this in your notes. It's called interval notation. And the way that interval notation works, instead of having to write a trillion numbers down or an infinite number of numbers down, what we get to do is we get to write the small number on the left. We get to write the small number on the left. And then we get to write the large number on the right, the large number on the right. Now, what do you think would separate the large number from the small number? Something's got to separate them. A comma. So we put a comma in the middle. We put a comma in the middle. And then what's really weird is when we put these things on the ends of them. When we put these things on the ends of them, we either use a parenthesis or a bracket. We either use a parenthesis or a bracket. And a parenthesis means do not include. A parenthesis means, you know, that number, it's like a boundary, but we're not actually going to include that number. Whereas the bracket means, you know what, we'll count it. We'll count that number. Count it. Count it. Include it. So perhaps, just so that we can kind of get a better idea of what's going on here, maybe I'll make this dot at the end of this. Maybe I'll say, you know, we're never ever going to cook 15 eggs. We might cook 14.99999 eggs, but if I put 15 eggs in my pan, Santa's not going to bring any presents to my house this year, so I better not cook 15 eggs. So let's see if we can figure out the domain now. What's the smallest number in our domain? 0. So when we write the domain, we're going to say, okay, the small number is 0. And what's the largest number? 15. It's actually not quite 15. It's 14.99999999999. But instead of having to write all those nines, because we're going to include 0, we're going to put a bracket here. Because we're not including the 15, what do we put next to the 15? A parenthesis. Okay? That's called interval notation. It makes life a lot easier. It makes life a lot easier. So then the range. What's the small number for the range? 0 and the big number? Looks like 2. Again, bracket because we count the 0, parenthesis because, dude, if I put 2 ounces of grease on my pan's going to explode. Santa's not coming to the house. The Easter Bunny's not going to hide a basket under my tree. Is that how that works? There's too many holidays to remember. I don't get them all. How do you feel about this interval notation? You think you could figure it out as the year goes on? Good. All right. Moving right along then, a function, we say a function is a relation in which each element of the domain corresponds with exactly one element of the range. I've seen that definition hundreds of times, literally hundreds of times, and it's never made much sense to me. If you take pre-calculus, they talk about this idea of being 1-to-1. Meaning each element of the input has one element of the output. Remember when we did this map thingy, we had the input and the output like that? Suppose we have a 2 and 2's mapped to 5. That particular element of the domain corresponds to exactly one element of the range. However, what happens if I have 2 corresponding to a 6 also? What happens the second I do that? It's not a function anymore. Okay? What ends up happening in that scenario is when I have just the 0.25, everything's great. When I have the 0.25, everything's terrific. Bam, there's 2.5, right? There's 2.5. Well, the second I go bringing in this 2.6, the second I go bringing in that 2.6, watch what happens. Doing 2.6. Anybody know what's going to happen here? What test we use? Oh, the vertical line test. Nice. Somebody brought their A game on today. Right on, right on, right on, right on. The vertical line test. Yeah. Remember, if a vertical line goes through more than one point at any given time, then what happens? Then we don't have a function. Then we don't have a function. The interesting thing is with the map, if we look at this map, what could we look for? What could we look for with a map to see whether it's a function or not? If there's how many arrows from one input? If there's one arrow from one input, we're okay. But what happens if there's more than one arrow from an input? Then it's not okay. What if we had something like this? What if we had something like this for our map? What if we had an input and an output and we had the number 3 here, and the number 4 here, and the number 5 here, and the number 6 here, and we just had the number 1 here, and all these arrows pointed back to 1. Is that a function? Let's think about what the graph looks like. If we graph it, we're going to have 3-1, we're going to have 4-1, we're going to have 5-1, and 6-1. Does that pass the vertical line test? It sure does. So this is okay. This is a function. How do you feel about recognizing whether this is a function or not? Does it make sense? Good. Well, let's think about ordered pairs. Let's think about ordered pairs. Suppose we have something like 3-2, 4-5, 6-7, 3-4. Is that a function? Maybe we should graph it. 3-2, 4-5, 6-7, 3-4. So what are we looking for to determine whether ordered pairs are a function or not? Oh, if the x's are the same, yeah. So the dead giveaway here is if the x's, let me try that again, get my right highlighting box. If the x's are the same and the y's that are attached to those x's are different then, right? So if we see a repeated x value, we can kind of say, well, it's probably not going to be a function. So with ordered pairs, we're looking for repeated x values, right? If there are repeated x values with different y's, with different y values, then it's not a function, right? Repeated x values with different y values, it's not a function. And the table basically is the same way as ordered pairs, right? You should hear the question that I'm going to ask on an upcoming test or quiz. I'd love to share it with you, but I can't because I don't want to give anything away. But it's kind of an interesting question. I'm real bad about those cliffhangers like that. I'm sorry if that bothers anybody. All right, example 3. Is this a function or not? So let's look at part A. -3 gets mapped to -2. 0 gets mapped to 7, and 4 gets mapped to 1. Is that a function, yes or no? I'm hearing yes, I'm hearing no. What do we think? Maybe we better graph it. If you're not sure, graph it. If you're not sure, graph it. -3, -2, 0, 1, 4, 7. Is it a function? It is. Number B, is it a function? How do we know? Because this 4 and this 4, right? So when we graph that, we would have 4, 1, and 4, -1, right? Okay. So that one's no. Number C. What do we think about number C? C is yeah. C is no. Which is it? What do we say about the arrows? If there's more than one arrow from a member of the domain into the range, then it's not, right? So if we think about number C, that 2, -3 is going to be down here, and 2, +3 is going to be up here, so number C is a no, all right? So with those maps, if we see more than one arrow going out from the domain, it's not. Got him? Everybody feel all right about this? There's really only one more idea we need to talk about today. And we've already talked about it this year. Real quick, let's look at some vertical line test ones. Number A, is it a function? No. Number B? Number C? Okay. So did everybody feel okay about the vertical line test thing with the graphs? Good. The last thing we need to talk about then is F notation. I'm going to show you again on the calculator how to assign a function, how to define a function, how to evaluate it, and I'm going to show you something that your algebra teacher should have showed you, but they didn't. And I normally wait until chapter 5 to show you this, but I'm going to show you this. What is this, the third week of school? I'm going to show you the coolest thing ever, the third week of school. Okay. So here we got f of x. We got f of x is this -2x plus 5. And they want us to find, when they say to find this, they basically want us to find f of -3, right? So that's going to be -2 times -3 plus 5. And I think most of us know how to multiply -2 by -3. What's that? That's +6. So we have 6 plus 5, and 6 plus 5 is 11. So what ends up happening is f of -3 is equal to 11, right? Some people get that. Some people are like, dude, what do you do with the -3? Nothing. What do you do with the f? Nothing. That's it. That's your answer. So what I'd like you to do, if you have a calculator handy, if you don't, go ahead and take a minute and grab one. I'd like you to realize that you can actually have the calculator do these for you. Like I always do about this time, I start with a new document, I don't save changes, and I go and add a calculator page. I add a calculator page. And I type in on a calculator page, I just type in D-E-F-I-N-E, define. Did you notice how when I'm typing it's italicized, and once I'm done typing the word define, it's not italicized? You know what the calculator's saying? I can do this, dude. I'm ready for you. All right, dog. Hit me with what's next. What's next is a space. Not the final frontier. Did you guys know how many ears Dr. Spock had from Star Trek? He had 3 ears. His left ear, his right ear, and the final front ear. Anyway, the space button is next to Z. The space button's next to Z. So we're going to define space, and we're going to type f of x. Now, instead of writing of, we need a left parenthesis. So f left parenthesis x. Now, do you notice where the cursor is, how it's inside the parentheses? I need to move the cursor beyond that, past that, to the right of that. So f of x equals, what was it, -2x plus 5? -2x plus 5. Bueller, plus 5. There we go. Enter. And it says done. Now, what did we just find? We found f of -3, right? We could type that. F, left parenthesis, -3, and there it is, 11. Yay! There were 2 other values it wanted us to find. It wanted us to find f of 0 and f of 1/4. I could do both of those at the same time. I could do f of, and I'll show you the listing some other day, but 0 and 1/4, and it'll find the other 2 too. You can actually have it find as many as you want, as long as you're plugging in numbers. Okay? Are there any questions, comments, concerns, short debates, long debates about using the calculator to define and assign? What I want to show you now then, and this is it, we're almost done, I promise. Suppose f of x equals 6x cubed minus x squared plus 3x minus 5. And you had to find f of negative 2. Without a calculator. I'm going to show you something that your teachers should have shown you long ago. And of course, we'll check it on the calculator. But I want you to see this. I don't have to cube anything. I don't have to square anything. I don't have to do anything other than multiplying and adding. This is so cool. I can't believe I'm showing you this the third week of school. You see that little box right there? I'm going to put a number in there. Maybe you'll see where it comes from. Maybe you won't. I'm putting a negative 2 in that box. You see where that came from? Okay. Next to that box, I'm going to put a series of numbers. I'm going to put a 6 and leave some room, and a negative 1 and leave some room, and a 3 and leave some room, and a negative 5 and leave some room. Do you see where those numbers came from? All they are is the coefficients, right? I'm going to leave a little bit of space, and I'm going to put a line down here. And I'm going to do exactly what Snoop Dogg does when he sings that one song with the rollie on the arm and the pouring Sean John. I'm going to drop it like it's hot. Drop it like it's hot. Drop it like it's hot. I'm going to take that 6 and I'm going to drop that 6 straight down here. And all I'm going to have to do is multiply and add. Multiply and add, multiply and add, multiply and add. What am I multiplying? I'm multiplying this negative 2 by that 6. And what's that product going to be? Negative 12. And that product is going to shoot right up to here. So that product's negative 12. Now I'm just adding right down the column. I'm just adding right down this column. So what is negative 1 plus negative 12? Negative 13. So again, I'm going to just multiply and add. I'm going to multiply now negative 2 times negative 13. It's going to be positive 26, right? So that's going to be 26. So then that slides up to there, right? And then I just add down the column again. So 3 plus 26? 29. And now I got to multiply negative 2 by 29. That's a little bit tougher to do. 30 times 2, 60. So it's a couple less than that, right? What is it, 58 negative? 58 negative. So it's 58 negative, and then down this column I got negative 5 plus negative 58. How much is that? It's negative 63. Now wait till you see what happens. Wait till you see what happens. On the calculator, let's go ahead and define f of x as 6x cubed minus x squared plus 3x minus 5. So let's try that. So we're typing define space f of x equals, what was it, 6x cubed? And then what? Minus x squared? And then plus 3x minus 5. And we're finding f of, what was it? F of negative 2? Oh my gosh. What do you think? Is that some kind of crazy, wild magic math trick or something? You guys know Mrs. Carlson? We're about to give a shout out to Mrs. Carlson. Everybody knows that 5 squared is 25, right? Would you be able to square 115 without a calculator? I can. 11 times 12 is 132. This is going to be 13225. If you don't believe me, try it. 115 squared. Dude, that's really cool. Could you take 20 or 205 and square it? 20 times 21 is, I think, 420, and then it's going to end in 25. 205 squared. 205 squared. Dude, that's crazy. That's Mrs. Carlson. She taught me that. 55 squared. So what do we do to find 55 squared? We take This leading term 5 times and multiply by what? The one higher. 6. So 5 times 6 is how much? 30. And then we just drop a 25 on the end of it. So 55 squared, 55 squared, bam. Isn't that pretty neat? I used to do this one. What if we had 11 times 500, or 5,134? You ready for this one? This will blow your mind. Ready? No tricks up my sleeve. I don't have a calculator in my brain. Here we go. 5, 6, 4, 7, 4. 11 times 5134. 11 times 5134. 5, 6, 4, 7, 4. That one wasn't impressive enough. Let's try another one. 11 times 3, 6, 1, 4, 5, 2, 3. Somebody got a calculator? Want to check me? Here we go. It's 397,59753. How'd I do? Anybody see the trick? The first number is the first number. And the last number is the last number. But you don't multiply. You take 5 plus 1. What's 5 plus 1? Ooh. And then you take 1 plus 3, and that's 4. And you take 3 plus 4, and that's 7. You got to be careful when you do that. That's only, notice the numbers that are next to one another in the multiplicand. Notice that the sum of those has to be less than 10 for that to work. If they're not, it's a little trickier. Suppose we had 11 times 8, 6, 7, 5. Now I'm going to start on the other end. There's a 5. What's 5 plus 7? 12. Carry the 1. What's 6 plus 7? 13 with 1 carried, 14. Carry the 1. 6 plus 8 is 14. With the 1 carried, 15. And I got to carry the 1, and that's a 9. I think those are pretty fun. It's been real. It's been fun. I hope everybody has learned a thing or two about functions, domains, ranges, relations, F notation, the TI Inspire. I'd like to give a shout out to my 5B class for being so awesome. And I'd like to give a shout out to anybody at home watching this on YouTube. Have a nice day. Good.